Hello, my name is Theodore Mandilaras and I am about to present you our study about the evaluation of the effects of different tracker-driven direction sources on continuous artificial locomotion in VR. First of all, locomotion is used to move users' point of view in a virtual environment from one location to another. It is considered as one of the most widely used interaction components in VR since in most cases some kind of navigation is required. In order to provide the ability to comfortably navigate in a virtual environment and maintain a high sense of presence, researchers have come up with numerous locomotion techniques like real walking, walking in place, and teleportation. One of these techniques is continuous artificial locomotion. With this technique, the user moves continuously through the virtual space by pressing directional buttons on the controller. This technique is considered as one of the most common locomotion techniques and it allows to navigate beyond the confines of physical area. However, it is also strongly related to cause VR sickness. This sickness is induced from the mismatch in sensory information between the visual and other senses, and it can lead to headache, blurred vision, dizziness, and disorientation. Generally, the majority of the existing literature about locomotion is mainly focused on how to move the user and not to the direction of the movement. Most common direction sources are the headset or one of the controllers. However, this behavior not only may feel unnatural to the user, but also it overloads headset and controllers with navigation functionalities, which in most VR applications they are already used for other tasks. In this study, we propose two extra direction sources and we evaluate the effects of those sources in terms of users' performance, preference, VR sickness, and presence. Besides the existing hardware, extra tracking devices are being utilized in order to unlock different direction sources. In this way, we leverage full body tracking, which is considered as one of the industry standards of the next years. The selected direction sources are a headset based, in which the direction of movement is driven from the orientation of the headset, a controller based, in which the direction of movement is driven from the orientation of one of the controllers, so the user moves in direction that this controller is pointing at, a hip based, in which the locomotion is directed from the hip of the user. This is achieved by placing a tracker in that area. And the last one is a feet based, in which the direction is calculated from the angles of the users. To evaluate those direction sources, we are in the process of implementing a virtual environment. In this environment, the locomotion is enabled using continuous artificial locomotion based on joystick. During the experiment, the user will be trained with each direction source and they will be asked to execute three simple tasks for each method. The first task is to navigate into a zigzag environment, following a path as accurately as they can. The next task is to walk through a corridor while counting some dots that appear on the walls, and the last is to fulfill a simple interactive mini game. About our methodology, as I already told, our evaluation will be in terms of performance, preference, VR sickness, and presence. The performance will be measured as the time and the accuracy of each user. Preference, VR sickness, and presence will be assessed from questionnaires and an interview at the end of each experiment. With this work, we hope to contribute to the field of locomotion in VR. Thank you very much.